pretty much everyone who has done something very, very important in C++ is here at least every other year or so. Directly interfacing with those people is just an incredible boon to your career, especially early in your career. Getting to pick people's brains on things, just hanging out, talking with people, you can't put a price on that. And you don't get those online.
Hello, my name is Aaron Robinson, and today I'm going to be giving a talk about making libraries consumable for non-C++ developers. This is kind of towards the end of the conference, so it's a little bit this talk is intentionally designed to not be very code heavy. This is more conceptually what's going on. There is code in here, but there's not a ton, and that's designed because it's at the end of the week. Everybody has been seeing a lot of code on their slides, so I'm trying to let's understand the concepts, let's understand the problems. So it is a simpler talk, but the concepts that I'll be talking about here are incredibly troublesome for me. So who am I? I've been coming to CppCon for a long time. I'm actually a volunteer. I currently work at Microsoft, and I'm one of the owners of the .NET Interop system. But before that, how I started in this is my education is originally in social work. I came into computer science through various sequence of events, and eventually graduated. I did focus on computer science later in my career, and I came out of school and started working at the MathWorks. And at the MathWorks, the one thing that I spent a lot of time with was trying to get, or helping people write functions and logic in non-MATLAB language. So stuff like Fortran, stuff like Ada, C++, C, Java, C#. I was there for a little bit. I then moved on to Microsoft, and I worked on Visual Studio. I did a ton of things with the tooling in Visual Studio. Most of my focus was on the Visual Studio Profiler. There, one of my big tasks was, if you've ever used Visual Studio, it is a giant mess of interop. It uses C++, it uses C#, it uses JavaScript, it uses everything. I did a lot of the work for the VS Profiler. That was one of my things that I handled for them. A couple years ago, I decided to move a little bit on. I'm still at Microsoft, but I joined the .NET team, and I am, as I said, one of the owners of the Interop system for .NET. So that's who I am. Interop is really, really important to me. So let's kind of let's look at what is Interop. Interop for me is basically the idea of enabling two or more disparate entities to work together. This is kind of actually common for all of us if we are engineers. You may have a PM, you may have a business counterpart, and sometimes you're communicating with them and you're using different words. It's not really working. There's a lot of dissonance between the two conversations. In a similar way, I try to solve that for software. So the interop, when we talk to people about interop, at least in the software world, we hear things, this green area, which is connecting these two, the blue circle component and the orange square. When we're talking in this area, we hear things like glue code. We've all heard it. We've heard things like boilerplate. We've heard things like, it's just a nightmare, don't touch it, I can't deal with this stuff. I've heard all of these things whenever I talk to someone about how do I connect these two pieces of software. So for me, when I focus on that green part, when I'm actually looking at it and working in it, or if you're if you're owner of an interop system, you hear a lot of different terms as well. You hear things like ABI. I hope as a C++ developers, we've all at least heard of it and understand, or at least are familiar with its idea. You hear things about calling conventions, or I want to consume some other library. I want to call it from the blue circle, and I want it from the orange square, or the gray one now. Marshalling is another term that we hear that is pretty common to hear. There's a few other terms that I get asked, or that I have to think about myself. Something like, was I supposed to free that? Which is annoying. It's basically a memory leak in a lot of cases. But the one that scares me much, much more in the interop space is, was I not supposed to free that? This happens far more often than anyone would like to admit. So that is what interop is. The question is why? Why do we want interop? Why is it important? Why is it necessary? And the reason is that no language or platform is really good for everything. We have this term general purpose language. It's largely true, but it kind of obscures that if it's really, really general, it's not really good at anything. It's not really tailored. It's not specific for something. And so when people say this is a general purpose language, like, yeah, that's true, but it does shine in one or two areas, and that's really what's important. An example of this is that the blue circle software may have a fast inner loop. May make UX really, really easy. We can all, I'm assuming some people's mind is going directly to HTML and the browser experience. It's real fast inner loop, makes UX easy, and has great tooling. The orange square, different, may be high performance, avoids costly abstractions, could be just what the vendor provides. I don't really have a say in it. But that's the point here, is that not one is going to solve all the problems. And so that green connects those two, and that is the interop. That is what we're focusing on. The type of interop, this particular graphic that I'm showing here, that green component can imply something. And what I mean by that is, where's the process boundary in this interop experience? It wouldn't be uncommon to say that this is the process boundary. This would be the classic microservice component. You have a bunch of microservices, the blue circle is one component, and then the orange square is another, and then they communicate, but they're not in the same process. That's not what this talk is. Microservices and how to do inter-process communication, all those kind of things, that's a very different topic. Some of what I'm going to discuss in here is related, but for this, we're going to focus on the in-process interop. So just to be clear. Some approaches that we can take with this. This is a list, and it just demonstrates some general ideas. If there are others, I would love to hear about them. Please follow up with me, because I've been doing it a long time, but I don't know all of it for sure. Post 72, there's a common approach is just be like C. Just make it compatible and it'll work. It's very similar to the C++ model. Just make it work with C and everything works. Another approach, I do work at Microsoft, is the dreaded COM model. And I'm sure people have heard of it. I have yet to find anybody who really enjoys it, but it is a thing. COMWorks solves interop in a very interesting way. What it does is it defines the contract, or what I call the source of truth, in an IDLE file. You define your API, and from that source of truth, you can generate code. You can generate artifacts for VB script if you want. You can do it for JScript. You can do it for .NET. You can do it for C++. It'll generate a bunch of headers. But what's interesting there is it's in a language neutral. It's in a neutral language, not what you're targeting. So it allows to target other things. That's one approach for solving this interop problem. Another approach is foreign function interface. I'm sure people have heard of that. That's kind of what Python does. That's one of the tools that Python uses to consume external libraries. The foreign function interface is interesting because it allows you to programmatically consume functions. You can actually call a specific libffi, and it will, at runtime, you can point at libraries and consume functions. You can discover them. That's one approach, and it has a very high level API for consuming other functions. Another approach is SWIG, which is basically the source generator approach. The source of truth in this case is header files. It actually reads C and C++ header files, and it generates C#, it generates Java, any number of things. Another approach was that the JVM took. The JVM approach is, and this is very targeted to the JVM, what this does is it exposes a very comprehensive C API that can be consumed in C++ pretty naturally. And what it requires of the Java developer is to implement during compilation of the Java module, it will generate a header file. You can take that header file and you can implement it. And then you can call whatever C or C++ you want. And that rich JNI API surface area allows you to translate some sort of Java string or Java array or Java object into whatever is interesting in the C or C++. .NET has a slightly different approach. And what this does is instead of like Java, where like the JNI approach, where it generates a header file that the Java developer may implement, .NET takes the perspective of let's let the consumer stay in the language that they're writing in. So if I'm in C#, I just want to write C#, so it allows me to declare native functions that I can call and consume them. And the .NET runtime helps there a lot. It's the same thing with COM interop. How COM is designed allows COM interop in .NET to be very lightweight as far as interop is concerned. And lightweight, I mean easy entry, not easy, and not high performance in all cases. C++ CLI, if you've never heard of it, let's try to keep it that way. It is a very complex solution Herb Sutter, who's here, was very much a part of. It is very, very clever. It is actually, it supports C++, you can write C++, but C++ CLI has some, and it looks very similar to C++, but it uses carets for managed pointers. It uses percentage signs for managed references. So you're a wash of asterisks, you're a wash of ampersands, percentages, and carets. It looks very odd, but you can write regular C++ and consume it pretty naturally. That's kind of an interesting approach. And so that was a very clever way of doing it. I don't think it has personally stood the test of time, particularly as someone who owns partial support of it. It is very, very complicated from an implementation standpoint. JNA is another approach that Java came up with. It's almost identical in spirit to the platform invoke in .NET. You can just stay in Java, write what you want. Go has a fascinating approach that I find very interesting. In your Go file, you write C in comments. And during compilation of the Go file, it's compiled into your Go binary. And so you can consume it directly, and it's really kind of interesting. You can consume header files, you can provide linker flags, all that kind of stuff. Swift does it even differently. Swift consumes or uses the Objective-C runtime. Objective-C can be consumed and supports C. So by transitivity, it can consume C. So you can kind of just stay inside of Swift and consume C things or Objective-C. The point of this is that there is no one approach. And that kind of sucks, because I can tell you right now, none of these are perfect. In almost all cases, you're going to find a bug. You're going to find something terrible. And it's going to be niche. It's going to cause you to lose sleep. And it is going to cause crashes for your users. It just is. And you're going to have to tweak whatever's generated. You're going to have to add metadata to any of these functions. It's very hard to get right. And that's the point. There is no one approach, and they all suck. I wish I could be more optimistic about it, but that's just the truth. Unless you're doing something very simple, at which point, success. But if you're writing a large application, it's really, really hard. We can make it easier. We can make it better, all of us, as C++ developers or library authors, by looking at some of the assumptions that are baked into what we write. So in this case, what are some of the assumptions? Does anybody see any assumptions in these definitions? The biggest assumption for me, if you come to C++, there's been a lot of talks on this, is the char. Char star irks me a lot. And and the W string view also kind of irks me because of something that's implicit with it. Char and wchar don't really tell me a lot. They don't tell me what I really want to know as an interop, as a consumer of this library. I don't know the encoding. Is Open Device going to accept a UTF-8? Or is it just going to accept some sort of ANSI code page, which, if you know what that is, I'm sorry. Same for wchar. What is it? Is it UTF-16? Is it UTF-32? I don't really know. And it's worse because the size of a wchar is different based on platform. So I can't even assume, oh, if it's always 16-bit, maybe it's UTF-16, sure, I'll punt and do it. SQLite, if anybody's ever used SQLite, they have a really interesting model. They won't even use wchar_t exactly for this reason. They use void star. They have a function, they have an open string, an open function that takes a string. They have a char star that they fully document and say, this is UTF-8, great, thank you, I appreciate that documentation. But when they have an open 16, they use void star for exactly this reason. And by the way, the open 16 is because it's UTF-16, but they can't use wchar_t because on non-Windows platforms, it's 4 bytes, which is kind of weird. Basic string, I'll get back to that. That has memory implications, and so we'll discuss memory in a minute. But those are some assumptions here. What about this? This is a pretty simple function. It's just GetSize. So you pass in a size of t, and it returns by pointer along. So my non-C++ language, let's say .NET or Java, is consuming this GetSize. That signature is pretty clear. C++ binary provides it. But what does that long tell us? Problem is not a lot. Because GCC and Clang, size of long is the size of t. But on Windows, size of long is always 4 bytes. Full stop. It just is. So long doesn't help me very much because I'm missing something. Now, everybody could say, all right, wait a second. If I'm on Windows, if I'm using MSVC, it's a long. If I'm on Windows, it's a long. It's 4, I know that, great. Or if I'm on GCC, it's 8, or size of t, great. Appreciate that. Who here uses Cygwin? Anybody? Raise your hands if you've used Cygwin. Nobody? Okay, 1 person, 2, 3. Cygwin has a version of GCC that's compiled for Windows on the Windows platform. And when you compile it, absolutely long equals size of t. That's great. So, all right, clearly whenever it's GCC, it's size of t. Has anybody heard of MSys2? It's another similar thing for, right. MySys2 compiles GCC, but size of t matches the Windows semantics. So GCC isn't the if you're using one of these subsystems that allow you to compile on Windows with GCC, you have to know that. So, those few things, what can we do? We can document what's going on here. C++ in the last few years has really pushed forth precision. We have int64 of t. This helps me as the interop developer or as the interop helper to do that. It helps me help people that are going to have a problem. Okay, this is actually 32 bits or this is actually 64 bits. Same thing for width. The int we could debate, there's pretty strong convention. But encoding, it's a no-brainer. Encoding kills. It really does. That's a simple one. Let's look at something a little more complex. What isn't being declared here? What? I'm sorry. How the ints are packed. Oh, packing. Yes, that's very true. That's very true. That's similar to what I'm getting at. Yep. What is it? Endian. That's another one. Really, these are both very good. I like it. The one that I'm looking for is, how is that size of t passed in? And how is that data of underscore t returned? That's actually not defined here. Now, if you're all inside of C or C++, you're right. That's not even interesting. I don't care how it's passed. That's not my problem. But if I'm consuming it from a Python runtime, if I'm consuming it from .NET or Java, I need to know. I don't know from this. And the reason I don't know is called calling conventions. And if you've heard of them, it's a sad state of affairs. It's a better state of affairs nowadays, but you go back 20 years, it's a sad state of affairs. So I don't know what's being used here. And let's look at a specific example. I'm just calling this function. I'm just going to call it. So from C or C++, I just call this. This was just going to work, not even a problem. But if I call get data from, let's say Java, and this is perhaps caller cleanup, which is a CDECL convention. This is x86, 32-bit for everybody. If we notice, after the call, I clean up the stack because the caller cleans up the stack. So if I call that from Java, calling it, I need to know to clean up my stack. I have to know that. If it's a callee cleanup, which is std call, this is far more common on Windows. Apologies for those of you who are not common using or more focused on Linux or Mac OS. Callee cleanup, the callee cleans it up. So if I call this and I assume std call and I assume CDECL and it is std call, I'm corrupting my stack because I'm cleaning up the stack when I shouldn't be doing that. So that's just one simple example. Let's take something that's a little more annoying, let's say. And this is very Microsoft. Now, we have the left side. Same thing as before, so I'm going to call it. And it takes the size of t. And on the other side, I have, interface dev underscore t, and it has a simple function and with no arguments. But we think back to, well, how does C++ actually make this work? One implementation, one possible way is to pass the instance as the first an implicit argument into get data from on the right side. That's one possible way. So technically, the free function on the left side and the member function on the right are more or less the same. They have the same signature, more or less. They're both taking a size of t, they're both returning data underscore t. Assuming that we're doing a callee cleanup, let's just assume that, and focusing on the return type, is the return type the same from both of these? We've all kind of decided that, yeah, their signatures are basically the same. That's true. Unfortunately, and again, this is a Microsoft thing, unfortunately, but it's something that I have to be concerned about, and Interop people have to be concerned about. It's slightly different. Because if it's a free function, you can see the add on the left side, it's just adding EAX and EDX. That's all it's doing. And that's because data underscore t is just 2 ints. So it knows that, and it's, this is quick, this is fast. But on a member function, for std call or CDECL, it's returned in a buffer. Caller allocated buffer. It's not returned in registers. It's the exact same calling convention. Std call. But it's fundamentally different whether it's a member function or a free function. one more, let's look at something else that I'm sure everybody here is familiar with, and I know because if you've heard of ABI, you've heard of this problem. What else isn't being declared? Packing was great. Unfortunately, that's not what I'm looking for. And the endianness, also good. Love it. I don't really like this function because I don't know how it fails. If I pass in -1, what is it going to do? It's going to AV. Is it going to... I also don't know, or someone doesn't know, if I'm consuming this, is the consumer or the library assume, what are these flags, what flags was it compiled with? Is the consumer compiled with, is it ready to support those flags compiled in the same way? I have no idea. Throwing an exception between, and the consumer isn't ready for it is a very bad thing. It's a very bad thing. If you throw an exception and your consumer, the Python runtime, isn't ready for it, it's going to fail in a way that you don't even want to think about. And you're going to get a core dump, you're going to get a dump file or something, and it's going to be completely inscrutable. You're not going to be able to get anything out of it because it's going to try to walk the stacks and it's just going to fail very, very quickly. And or it could pass and it could AV beautifully and you'll see it and it'll be great and captured. That's rarely the case for me because I don't know what flags either side was done with. Beating on Windows a lot here. They're doing weird stuff. Haven't even discussed, we could discuss structured exception handling, which is its own set of mess on Windows. Let's look at other platforms. This is an Objective-C runtime, as I mentioned before. This is exported. This supports C consumption, great. We look at this and I can tell you that ID is a void star and capital SEL, that's also a void star, basically. It's not exactly what it is, but it's the general idea. What this tells us, what this declaration, all of us in here can read this pretty easily, is that it's variadic arguments. Great, love it. I can pass anything I want there and it's just going to get called and it's wonderful. But is that really what this is? And the answer is no, it isn't. Because this is how I would call it. This is exactly how I would call that definition. If I was a C developer or if I was someone else, and remember, this is just interop. I'm consuming this from the Objective-C runtime. The appropriate way to call this is this. You actually have to cast it to the signature that you want to call. The reason for this is because as a C or C++ developer, I want to interop with Objective-C in a really interesting, in a simple way. I don't want to write Objective-C. And if you've never written Objective-C, try it and see for yourself. But that's how you have to do it. Apple finally fixed this in 2019. They declared it properly. Instead of lying to people and saying, oh, this is conceptually what we want. Like, no, it's void star, you can't call it. You have to cast it. And they updated their documentation and they made it clearer. Why did I find this? Because for .NET, I was working on helping to add support for Objective-C interop. This cost me about 3 days. This was very, very painful. So what do we see here? Again, we can make it suck less by documenting, understanding what assumptions you are making and understanding what assumptions your consumers may be making based on what you're declaring. Tooling can help here. I saw a really interesting talk yesterday about Clang's AST matching thing. You can do some code gen with that. It helps. But interop needs to know this information if I'm going to be able to consume it. And so if you're writing a library and you want more people to consume it, thinking about this will make it easier for others to consume it. I'm going to move on to something that is probably the most difficult, the most annoying, and that's memory model. And there's going to be a lot of opinions about this, and I want to hear them, most of them. Manual memory allocation isn't really suggested anymore. We have unique pointer, we have shared pointer, stop calling new, stop calling delete. That's what we constantly hear. Heaven forbid any of us call malloc or free. Just don't do it. So let's just assume that that's not what we're doing. Which means if we're not really calling those, we're using shared pointer, we're using unique pointer. What we are really doing is a form of garbage collection. The statement that I just made is contentious. Is reference counting garbage collection back and forth, back and forth? I'm not interested in it. It's not terribly interesting. It has certain rules that need to be followed. That's the point. This book is the dragon book, which I'm assuming we all know, compiler book. This is the dragon book of garbage collection. This is a brilliant book, and I highly recommend you get it if you are going to be using or helping to expose data to other people, to other runtime, whoever platforms, other runtimes. There's two general broad categories here. There's reference counted, which is a COM thing, which is shared pointer. Python has reference counting. ObjectiveC has reference counting. It's got an automatic mechanism, which is phenomenal and very weird. Swift has automatic reference counting. I said COM does. If you've used COM, add ref release right there. Another approach is non-reference counting. It's kind of like an implicit thing. Like, don't worry about it. There's some entity that's going to figure it out for you. .NET has it for the garbage collector, JVM, Java, there's others. Let's look at the three things that I've mentioned just briefly. Memory is allocated and deallocated directly in the manual approach. So I have my orange square, it's going to allocate some memory, and I want to pass it over to the blue circle software. So it can pass over the pointer, and notice that I put a little comment there. It's at 2600. That's the memory address. It's going to, in manual, it's not going to move because I've allocated it. I put it there, they can be used, and then I can pass it over and I can delete it. That's great. The left side could have deleted it if it wanted to. Didn't have to, but it could have if it knew what the allocator was. It's very simple. You could change new to malloc or do whatever you want with it. Use any other allocator that you wish. Reference counted models is slightly different. It's typically explicit. It's tracked explicitly through reference counting, but it's implicitly handled. I'll show you how that, we'll see how that works. The memory allocation in this case is also typically static. If you allocate it at a specific address, 5200, it's going to stay there. Likely going to stay there, regardless of which side, typically. One small note here, ref of 0, this is another contentious opinion in the garbage collection world of reference counting. Does it start at 0 or does it start at 1? It's not terribly interesting, but there are arguments on either side. I'm starting with a ref of 1. People do say when you create, it should be 0. That's just the thing. But in this case, let's say we pass it over. It goes over to the blue. We add ref. This looks like ObjectiveC. That wasn't the intent. It was just some different dispatch semantic. Now it's at ref 2, but 5200, it's always at 5200. Both sides of the software can interact with it in a direct way. They can call it through any of the options that we discussed at the beginning. And eventually it's 5200 and ref is 0, and when it gets ref to 1, and then ref to 0, and then it gets freed implicitly. So you never call delete or new. This is shared pointer. It's not terribly surprising. But this is completely reasonable in a interop scenario. This is absolutely a Python scenario. Makes perfect sense for memory. What about in a non-referenced case? So I moved to the other side because I hope people are following that the blue square, we could be C or C++ in principle. So we're now on the orange square. So now we're on the blue circle side. We're starting over there for some odd reason. And I'm going to allocate something, and it's at some address. I'm going to also allocate a handle, and we'll get to why that is. Because in a non-reference counted area, the memory lifetime isn't explicit, it's implicit. That's that garbage collector. There's some other entity that's figuring that out for me. It's not the reference counting, it's something else. And in this model, because this other entity is handling that, the allocated memory may not be statically, the address of it may not be static. And that's where that handle comes in. We're going to get to that. So we pass over the handle to the other side. And I have the 9200 and it's pointing to the 7800. Great. And the sys underscore query, let's say that's provided by the blue. Probably should have named that a little bit better, but that's what that is. That's a function that is provided by the blue circle to the orange square. And so it passes the 9200, that handle through, and when it dereferences it or jumps from it somehow, some level of indirection, it gets to 7800. That's great. But let's say on the blue side, the blue circle side, a collection occurs. And it could be a copy collection. It could be a moving collection. There are a myriad of different collections. Please read this book if this is relevant to what you want to happen with your software, or you already are a provider of it to other types of platforms. Because of that collection, the object is now at 6800. Any number of reasons. And let's say now the orange square calls, I want to call something. I want to call it again. I want to query it. I want to do something with that object. I want to use it. That's what that handle is. That's why that handle exists, because the handle doesn't move, the object moves. Because the handle isn't necessary in most cases. I just create a new object in Java and I pass it around and every other object can use it. You don't ever create a handle. But because I'm interoping with it, I am creating this handle, this stable holder for me. So that works. If so the collection occurred and then I made a call on the other side, there's no race, that worked. But there is an inherent race condition here, because what happens if they happen at the same time? How's that gonna be addressed? I have no idea where it is. And the point here is, this sys query may be a blocking call. It may block, because it can't look at it if the GC is going on, because it could be in the middle of being moved. So when you call into that other runtime, that could be a block. It may not be a block. Maybe this GC is not happening, but it absolutely could be. So then we call it, so that's why that level of indirection works. That's why that level of indirection is important. So how do we handle this in the end? Let's say we like to generate a bunch of code. Swig does a bunch of code generation for you if you want. There's other tools that will do a bunch of code source generation for you. And let's say you do the sys done, you're done with your C++ side, and in the destructor you call sys done. Sounds great. You'll call the other side, and in that implementation of sys underscore done, that API that was provided by the blue circle, it frees it, releases that handle in some way, and then the GC can happen and it's free. And that's the kind of dance that goes back and forth. But the point here is that it is only one possible sequence. GCs are by design non-deterministic. That is really, really important. Let's look at a little bit on the handle thing. I want to kind of just make a few notes about that. And there's one other little thing that is another option for the blue circle. The common ways of facilitating interop scenarios with the garbage collector are kind of two. There's the handles, which we just saw. It gives you that level of indirection. This is usually required by the platform, whatever that blue circle is, whether it's .NET, whether it's Java or the JavaScript world. .NET has the GC handle. That's how you would do it. It's a very straightforward API. The JVM doesn't have it directly, but it has it through the JNI layer. It doesn't actually pass a void star, which is a string. It passes a JString to you. And then it provides a rich native API surface that allows you to interact with that. But that's really what it is. It's a handle to the string. It's a level of indirection. So as you can imagine, it's not cheap. It's expensive. It can be very expensive. Another way, which is possible, is you can say, yeah, I don't want you to move it. Don't move the object. I don't want you can tell the GC, don't move this for me at all. Whenever you do it, just please leave it where it is. It's called pinning. Again, .NET has a mechanism for this through the fixed keyword. You can actually say, if like you have a value type that only has a bunch of ints, let's say it's statically allocated, but it is on the heap, the GC heap, it can be moved. The GC could do that. You could put fixed during the interop scenario and it'll say, GC, I want to use this and you're not going to be aware of what's going on, so keep it there for me. Completely works reasonably well. It works very, very well. It's very safe. It is safe. Conforming JVMs do have this concept. I have yet to find one that implements it. But if you look at the JNI API, it exists. It's on there. So those are the two distinct approaches for this. There are probably others, but those are the two main approaches. Memory model. The control of this shared memory when you're going between these platforms, it really needs to be documented and agreed upon. Are you going to use alloc on both sides? So if in that one example, if we knew that you were calling delete, or the C++ side, the orange square actually said, call this function when you want to delete something, that would work. But you have to have that contract. You have to know how is memory being used. Also mentioned that because when I'm calling back in, when the orange square is calling potentially back into the blue circle, it could have GC could be occurring, so it could be a blocking call. So immediately, everybody should be thinking, it's probably like expensive it's probably an expensive call to make. I may not want to make that all the time. That's something important. So chatty interfaces in interop, they don't work. Just if you care about performance, don't do it. The more chatty, the worse. GC makes this really, really complicated. So you have to understand how your consumers are thinking about consuming your code, your libraries. You really have to think about it. Even with reference counting, determinism is not guaranteed. And the reason it's not guaranteed is because the classic cascading deallocation problem. If I have a map that is a shared pointer, the last handle to it that gets released could release a lot. And that's going to block. It's going to stop. That thread is going to release everything while it dereferences everything to zero. It's expensive. It's incredibly expensive. So in some cases, even in a reference counted world, there's another thread that's sitting there doing something. And it's looking at reference counting. And it's like, do this when you're idle. Do this when you have time. Because I don't want you to do it right now. So that's actually a very common pattern as well. Ways to mitigate this. Because chatty interfaces are no good. Because contracts are very difficult to properly convey, and you may not necessarily want to add some sort of universal deallocator for the blue circle or for the orange square. A consideration is understanding alloc and dealloc callbacks, or at least thinking about consuming those, providing those. Maybe the blue circle is going to call into the orange square and say, I need my API that I'm calling is going to be returning a very large buffer. Might actually be very beneficial to say, you know what, tell me where you want me to write this. That is incredibly helpful from the interop perspective, because it's like, okay, I will give you something, you'll call it when you need memory. That's great. And because you're going to return it back to me, and then I can handle it however I need to handle it. I can handle it efficiently. It's not the chatty back and forth. Or in the worst case, I don't know how you allocated it. I don't know how the C++ allocated it. So I'm actually going to return it. I'm going to consume it, but I'm going to make a huge copy. So you gave me 2 megabyte buffer. I don't know how you're going to allocate it because I need to manage it myself. So I'm going to copy it immediately because I don't know how you're going to use it. This is really, really a problem with strings. The reason being a lot of other runtimes, particularly Java and .NET, have a very specific way of dealing with strings. They have to be managed by the GC for reasons. So again, we have making this suck less. For memory, again, explicitly state your ownership rules. Explicitly state what you expect. Consider callbacks because they can be costly if they're the chatty interface. We have to do very expensive copies. This last one, who here has done COM? Do we have a show of hands? Anybody who's done COM work? A few people. Limit implicit models that force memory to have thread affinity. This is the classic STA, MTA in COM, if you're familiar with that. That doesn't mean that you can't have a memory pool on a thread. It's not what I'm saying. What I am saying is if you are required, if that thread is the only one that is required, or it is required to allocate or deallocate that memory, that is a problem, especially in a GC environment, because of that maybe that other thread that's going to deallocate something later for you. Because that's the thread that's going to potentially call back, not the thread that allocated it. So thread affinitized memory is okay, but it should be freeable from anywhere because you don't necessarily know how it will be deallocated. And that's not something that you have to permit, but it is something you have to consider depending on who you think is going to be consuming your library. And the last one, because as I said, I did work on Visual Studio, consumers of your library may have specific tools. And as C++ developers, we tend to sometimes do clever things to make things more efficient. And that can play heck with the tooling for Python. That can play heck with the tooling for .NET. Those are just things to consider. And that's what this is all really about. It is about trying to convey your intent, your assumptions, your desire to be a consumed by everybody library. That is what everybody wants. Everybody should be using my library because it's the best library ever. But if it's designed in a not friendly way for other people, other non-C++ developers, they can't consume it. It's impossible. Or it's not necessarily impossible, but eventually they have to call someone like me, and I get to spend 4 days literally debugging at the assembly level to figure out what calling convention are you using? Or what's your memory allocation scheme? And so what that is document what you want and assume. Understand the assumptions and be precise when possible. This is what is the encoding? It's a simple thing that everybody can do. And it's not hard, it's top of the documentation. We only use UTF-16. We only use UTF-8. The correct answer is only use UTF-8. I think we can all agree on that. I hope we can all agree on that. And honestly, there's been a ton of talks here at CppCon about encoding. I highly recommend reading them and at least being familiar with them. And one other thing, interop scenarios often aren't using a C++ compiler, and that is the crux of this problem. It really is. The compiler's not there to help. So a lot of times it's a user or a tool that was written by a very clever individual 5 years ago. They no longer maintain it. Kate Gregory gave a great talk a couple years ago, and it's what do we mean when we say nothing at all? And that is really very relevant to this. It's what am I assuming, and how can I convey that best to consumers of my library? How can I help them understand my assumptions and be successful in consuming what I am writing? And that is really the gist of the talk. Understand your assumptions, properly convey them so that other people can consume them. Other non-C++ developers. Because we all have our own language, we all kind of understand and use terms that make sense to us, but not every platform and runtime do. And it's really confusing occasionally. And very detrimental in some cases. And that's it. I really appreciate everybody attending. My email, my GitHub account, I want to talk about this. I really enjoy hearing about problems that the community is facing. Email me, tag me on GitHub. I will respond. Thank you. there any questions?
We have been discussing in SG15, like the possibility of maybe talking about how do you describe a pre-built library package. Is that maybe something that should be, like what calling convention, what all of those details should become part of the specification when we get like a pre-built library from someone?
The question is about SG15 and some of the consuming packages from modules and various things. I have been on that mailing list and I'm following it. Just lurking, I'm not really talking much about it. Yes, but the answer is yes. I've heard some great conversations about, hey, we should put what flags. I don't know who said it, but it was one of the, recently on that thread, someone mentioned, we want compiler flags and we want all these things. A lot of that information is encoded in there. So yes, that would be very, very helpful. Very, very helpful. And as much information as we can get, right?
There is an online question. Hi, Aaron. Where do Rust borrow checking semantics fit into memory model interop? Where do Rust borrow checking semantics fit into memory model interop?
Rust borrowing?
Rust.
Oh, Rust borrowing semantics. My experience with Rust, which it's a very, very clever language. Every interop that I have had to do requires making it unsafe. It's the first thing I do. I need to call something from Rust in .NET. I need to call something from Rust in C. I have to use unsafe. Rust's borrowing semantics are very, very similar to a static garbage collector. It knows it can figure it all out. But in the same way that when you transition from the blue circle to the orange square, the Rust compiler doesn't see it, so it can't determine it. So it has to be static. So how do they impact interop? Basically the same way as anything else. It's as any other interop scenario. It can't peer through that jump. So you got to make it unsafe, which means the borrower checkers, I give up. Can't do it. It's just like calling C. It's not, unfortunately, that's just how it works. Rust is very, very clever, but peering through that interop it has not solved that problem. It solved a different problem. Interop is still very, very hard in that case. If there's no more questions. Oh, go ahead.
Have you considered using something like attributes to kind of specify more information in terms of how the interface with the library could look like? For example, IDL allows you to specify, say, how you will marshal a type, right? Something similar to that where other languages could use that information and code it in the interface for a function or a class.
Yeah, so the question is about attributes. In the .NET world, we would call it adding metadata to give you that extra information that's not encoded inside of the signature. Are you saying on the C or C++ side?
Yeah, C++ declarations can provide that information
yep.
even if the language does not use it.
Right. That's true. That's clearly a solution. And I have no real opinion about that. I like attributes. I think they're interesting. I think that personally attributes are kind of a slippery slope. But they are very helpful in interop. Only concern is you need to be very careful that your attributes do not exceed the text that is the declaration of your function. That is the biggest problem. I have one other thing that I'm just going to quickly show you. I'm not going to answer it. Would love to see if anybody has it. Anybody can think about this, what this means. Or well, maybe I will answer it. This is something that recently happened to me. This was an unfortunate situation. Oops, yeah. So So I have a blurb. It's a struct value type, just a struct with a size of t, int. Let's assume that this is 64-bit because the do the thing, the blurb underscore t is passed in. And in .NET, we're going to call this, I wanted to call it, this actually happened, then it's been changed because I don't want to tell you exactly how ignorant I was being. I declared it as do the thing. It returns an int. That's a native int, so it's void size of t. And I declared it as an in blurb t. You can imagine that that's basically just a reference. Assume that that's just a reference in C#. That's what that means. Now that's not what do the thing says. That says it's passed by value, right? This passed and was correct on Windows. But it failed every time on Linux. On 64-bit, this is one of those things that interop, I said I had to debug through all this assembly to figure out what the heck was going on. Put this into Compiler Explorer. And look at, and change blurb to a pointer and see what happens. It's very, very similar. The problem is, I'll tell you why on Linux it fails every time, is because blurb of t, when it is passed by value, is passed in registers. But on Windows, that's not the case. So it was incorrect. It was clearly incorrect. That's a bad declaration, but it works. And these are the problems that interop people face all the time, consuming. Now, this is clearly my fault. This isn't anybody in here's issue, but that's kind of the idea. Yes?
You said it works. Do you mean it did the correct thing or it didn't crash?
It does the correct thing. It actually does the correct thing. Now, we could say that it doesn't because I'm passing it, but because of how it is stored, because of how that calling convention is, it actually works correctly. Yeah, it's a nightmare. Yes?
So, like, since you're knowledgeable about this topic, like, why does Windows pass this, or why doesn't it pass this over registers?
That's I am on the Interop team. I'm on the .NET team, not on the C++ team. I do not know. I just follow the calling conventions that I'm given. The question was, why does this work for Windows? That's the calling convention. I deal with it. I don't make the rules, I just follow them. I appreciate everybody being here. Thank you all.